Welcome to Ask and Learn.
We are asked to answer questions about recurrence relations that do not have constant coefficients. We're asked to consider recurrence relations of the form f of n times a of n equals g of n times a of n minus 1 plus h of n. In part A, we're asked to show that this recurrence relation can be reduced to a recurrence relation of another form. So we're given that n is greater than or equal to 1, and that the initial condition A0 is going to be C. Now, we're given that we should make B of n to be equal to G of n plus 1 times Q of n plus 1 times A of n and that we should take Q of n to be f1 times f2 all the way up to fn minus 1 over G of 1 times G of 2 all the way up to G of n. Then we have that B of n, as we already have shown, B of n is equal to G of n plus 1 times Q of n plus 1 times A of n, and substituting in the value for Q of n plus 1, we get this is equal to G of n plus 1 times f of 1 times f of 2 up to f of n minus 1 over G of 1 times G of 2 up to G of n times an. But since this is Q of n plus 1, this should actually be from f of 1 up to f of n, and from G of 1 up to G of n plus 1. And so we get the G of n plus 1s will cancel out, and we get f of 1 times f of 2 up to f of n over G of 1 times G of 2 up to G of n times A of n. We can rewrite this as f of 1 times f of 2 up to f of n minus 1 over G of 1 times G of 2 up to G of n times f of n times A of n. And then from our recurrence relation, we have that f of n times A of n is equal to G of n times A of n minus 1 plus H of n, so that this becomes equal to f of 1 times f of 2 up to f of n minus 1 over G of 1 times G of 2 to g of n, and this is going to be equal to g of n times a of n minus 1 plus h of n. And we can write this using distributive property as f of 1 times f of 2 up to f of n minus 1 over g of 1 times g of 2 up to g of n, and then in front of this we can put g of n times a n minus 1 plus f1, f2 up to fn over g1, this should be fn minus 1, g2 up to gn times h of n, and we recognize that this first term is the same as bn minus 1, or first, I guess we could recognize this is the same as g of n times q of n times a of n minus 1. And the second term is the same as plus q of n times h of n. And we recognize that this is going to be b of n minus 1 plus q of n times h of n. So we transformed the initial relation into another relation, which is a non-homogeneous linear recurrence relation. That's what we wanted to show for part A. And in part B, we're asked to use the previous part to solve the original recurrence relation. So from part A, we determined that Bn is equal to Bn minus 1 plus Q of n times H of n And so if we apply this recurrence relation repeatedly, we get Bn is equal to Bn minus 1 plus Qn Hn, which is equal to Bn minus 2 plus Qn times Hn plus Qn minus 1 times Hn minus 1. We get that this is equal to Bn minus 3 plus Qn minus 2 times Hn minus 2 plus Q of n minus 1 times H of n minus 1 plus Q of n times H of n. And it seems pretty clear that if we continue this, we can go all the way down to B of 0 plus, and then we start at Q of 1 times H of 1 and then add to that Q of 2 times H of 2 and go all the way up to Q of n times H of n. And this can be rewritten using sigma notation as B0 plus the sum from I equals 1 to n of Q of I times H of I And recall how b of n was defined. So we said that b of n is equal to g of n plus 1 times q of n plus 1 times an. And so if we solve this for an in terms of bn, we get that an is equal to bn over g of n plus 1 times q of n plus 1. And then substituting bn from above, we get that this is going to be b0 plus the sum from I equals 1 to n of q of I times h of I over g of n plus 1 times q of n plus 1. And recall that we made the initial value a0 to be c. So we have that b0 is equal to g of 1 times q of 1 a of 0, which is equal to g of 1 times q of 1 times c. And recall that this is equal to g of 1 times, and q of 1 is going to be, we have 1 in the numerator and g of 1 in the denominator. So we have that b0 is also c, and therefore we have that an is equal to c plus the sum from I equals 1 to n of q of I times h of I all over g of n plus 1 times q of n plus 1. And this is our answer.